Welcome back to V-Spice. In this session, we'll discuss about purging and pressurization. In fact, this topic, we have also uploaded few videos under methods of protection, wherein we covered, EXD, EXC, all those aspects. And this was left out. That's why I'm uploading this. Purging and pressurization. Okay. So you may ask, what is this purging and pressurization? Why it is needed? Okay. Yes. Purging and pressurization are essential practices in instrumentation system, especially in environments where hazardous gases or dust are present. Okay. So let us analyze from safety point of view. Friends, purging and pressurization helps the helps to prevent the accumulation of flammable or toxic gases within the instrumentation enclosure, within this enclosure. So that is the, advantage. So by maintaining a positive pressure with clean air or inert gas, this system reduce the risk of, explosions or a harmful exposure. So that is the point from safety point of view. Okay. So let us go into the details. Just talk about the definition. Okay. See, purging. What is purging? Purging is defined as the process of supplying a flow of clean air or an inert gas to the inside of an enclosure to reduce hazardous internal airborne impurities to an acceptable level. So that is the point. Okay. So here, friends, the flow we are passing, right? The supply of flow, right? So the flow must provide the enclosure interior with a positive pressure greater than the ambient pressure uh, to be sufficient to take the hazardous element out of the enclosure to this acceptable level. So that is the point. I hope it is clear. Okay. So there is some standards actually. We need to adhere to the standard also that require the internal air volume to be changed 4 times for the enclosure. If it is enclosure means 4 times per hour. Okay. And 10 times if it is for motors. Okay. This is the compliance actually. Then during the purging process, a minimum positive pressure of 0.25 millibar for a flammable gases or vapors and 1.25 millibar for combustible dust area must be maintained. So this is all about the purging, friends. Okay, now we'll go into the pressurization. Okay, so pressurization is defined as a process of supplying a flow of clean air or an inert gas to the inside of enclosure to increase the internal pressure above the external atmosphere. You got it? Here, we are passing this flow of clean air to reduce the hazardous internal inborn impurities to acceptable level. Here, we are passing this flow of clean air to increase the internal air pressure above the external atmosphere pressure, okay, thus preventing a entrance of hazardous element into the enclosure. You got it? So that is the difference actually. Okay. So, right. Although it is very similar to purging, pressurization is not used to clean out the impurities. That is the point. Right? Okay, good. So purging and pressurization concept, the definition is clear. Now we go into the concept. Okay. See, the concept of pressurization and purging allows the use of standard normal NEMA 4X or NEMA 12 enclosure in a hazardous location. That is the point. Very simple. Even the normal standard NEMA 4X and the NEMA 12 can be used in a hazardous area with this all purging and all. That's it, friends. Very simple, right? Yes. So to add on few more, purge and pressurization equipment must be attached to enclosure, supplying a flow of, it's just a connectivity, right? Supplying a flow of a clean air or an inert air gas to maintain a positive pressure inside the enclosure and to reduce the internal concentration of hazardous material and gases to a safe level. Okay. So how this process starts? See, the process starts by purging the interior of the enclosure, right? To remove the hazardous impurities to an acceptable level of concentration, right? So once these levels are met, the process changes to that of pressurization, meaning second concept. Okay, this change does not lead to a break in flow of air or a inert gas because it would be then be possible for the hazardous contaminants to enter or re-enter the enclosure, possibly leading to an unacceptable level. So that is why after purging, the pressurization also need to be there. Okay. So the first is the purging. Then once the purging is done, then we have to do this pressurization. Okay, pressurization now keeps the pressure inside the enclosure constant and above the ambient pressure so that the lower pressure, that is external hazardous atmosphere, cannot penetrate the enclosure. So that's it, all about the concept, okay, of purging pressurization. Now we see the types. What are all the types? There are three types of pressurization. One is a type X, very simple. It reduces the classification within the enclosure from zone 1 to non-hazardous area. Very simple. See, the original requirement was zone 1. But now we using this XF, we already, reduce the classification to non-hazardous, just normal, right? Then type Y reduces the classification within the enclosure from zone 1 to zone 2. Originally zone 1. Now it is just a zone 2. Then type Z. It reduces the classification within the enclosure from zone 2 to non-hazardous. So originally zone 2, but now with this type Z, it's a non-hazardous. Very simple, isn't it? Okay. Now we go into the detail. Type X purging or pressurization. Okay. So as I said earlier, it reduces the classification within the enclosure from zone 1 to non-hazardous, right? Okay. Earlier it was zone 1. Now it's simple, non-hazardous. So internal equipment, whatever is inside, can be rated for general purpose and non-hazardous. Very simple, correct? Yes. That is how this is defined. Type X. Okay. Here, one point, friends, here we have this purging system and other. We need to connect it here and there. Okay. So the purge pressurization system and the electrical power source must be interlocked. This point we need to take note actually. Okay. Yes. So interlocked. Yes. Then another point, as I highlighted earlier, the internal pressure must be maintained at 0.25 millibar to 1.25 millibar. So depending on depending on the external hazardous class atmosphere, whether it's a class 1 or class 2. The point is it has to be maintained and the internal pressure to be maintained at 0.25 to 1.25 millibar. And other point is the purge pressurization system and the electrical power source must be interlocked. Okay. Right. So that is the another type X. Now type Y. Here it reduces the classification within the enclosure from zone 1 to zone 2. Okay. So earlier zone 1, now with this type Y it is zone 2. So again, just imagine internal equipment, whatever is inside now can be rated only to zone 2. So no need to go with the zone 1 rating. So that is the point. And here one pointer. See in type X, I had talked about the power system and pressurized system interlock, right? But here no need actually, but we need to give a visual or audible alarm to notify the low pressure. Okay. So that is the another aspect. And as usual, we need to maintain the 0.25 to 1.25 millibar pressure. Okay. Internal pressure. Then type X, Z. So this type reduces the classification within the enclosure from zone 2 to non-hazardous. Okay. So earlier supposed to be zone 2, but with this type Z modification, we are going with the non-hazardous area. So ultimately, internal component can be for rated for general purpose, non-hazardous. That's it, friends. And similarly, the interlock between power and pressurization here optional only, but there should be an audible visual alarm to notify the low pressure. And internal pressure must be maintained maintained at 0.25 millibar to 1.25 millibar. So that's it, friends. Very simple, isn't it? So now, climax. What is the differences between X and Y? You already know, but I want to sum up. Type X type Z. The internal equipment can be rated as a general purpose equipment, right? Type X. Okay, I'll go back here. So internal equipment can be rated for general, right? Then type Z. Internal equipment can be rated for general purpose. Very simple. But for type Y, internal equipment can be rated for zone 2. That's the point. Then again, the timing. Purging time for type Y and Z. Type Y and type Z is based on the inlet airflow or based on the inlet airflow. The purging time for type Y and type Z is based on the inlet airflow rate to the enclosure. Inlet airflow rate to the enclosure. Okay. But type X purging time is based on the outlet airflow rate to the enclosure. Type X here. So this is based on the outlet airflow to the enclosure. Okay. So that's it, friends. Very simple. Then another point I already informed you, right? The removal of power to enclosure is not required on loss of pressure for Y and Z. But in X, actually, we need to disconnect the power on loss of pressure. Okay. We need to have an interlock. That's it, friends. And the last but not the least, type Y and type Z are cheaper than type X system. That's it. So thanks for watching and hope you got some insight on this pressurization and purging and the types. Thank you, friends, for your support. Keep supporting and keep watching. Take care. Bye-bye.